Welcome to the fifth lesson of our WireGuard VPN Mikrotik RouterOS course. In this lesson, we are going to explore the road barrier client connectivity to Paris office. So this road barrier, which is in Istanbul, will connect to the Paris headquarter network. For this to happen, we are going to have two different types of configuration. One of them will be full tunnel, which will tunnel all the traffic to the Paris office or via the Paris office headquarters when we activate the WireGuard VPN client on this Windows 11 Pro machine. And then we will have a split tunnel configuration. When we'll activate the split tunnel configuration, only the traffic which is destined to the network of Paris local area network, London office network, and Berlin local area network will be tunneled through the VPN tunnel, and the rest traffic will go directly to the Internet ISP router. So let's start. First of all, we need to create a peer configuration on the Paris office side. For this, we will connect to the Paris office router. I have already connected. We already have two peers here from the previous lessons, one of them to Berlin and the other one to London office. Now we need to create a road barrier peer. Let's click on plus and give it a name. Let's say peer for road barrier client. The interface is same, WG server. The public key we have to get from the Windows remote client WireGuard configuration, but we don't have it. So it means that we need to create one. The easiest way to create one maybe will be using this menu, which automatically will generate us public and private key pairs. But as for me, this part of auto generation is a little bit laggy still and is not working as it should be yet. So let's postpone it for now and focus on the manual creation of public and private key. How can we do it? One of the methods is to go to the WireGuard interfaces and create one more interface. Let's say test and let's say apply. As you can see, after we applied, we see the creation of new WireGuard test interface plus new public and private key pairs, which we can use in our Windows client configuration. So let's copy the public key, say copy, and paste it here. The private key is not necessary, endpoint is not necessary as we are the server, endpoint port is not necessary as we are the server. Allowed IP addresses. The IP address which we are going to use on the far end side on the client is 10.10.10.100/32. The pre-shared key, let it be generated automatically. And we will be a responder. And the persistent keep alive, let's make it 20 seconds as default on all our peers. And let's click apply. As you can see, the pre-shared key was generated. Now we need to create a configuration file for the Windows 11 Pro machine. How can we do it? I already have a template here for a split tunnel. Let's open one for the full tunnel first. So I have a template for the full tunnel where we say road barrier client configuration. The interface private key is set, but in our current implementation, we have generated some other private key for the client. So let's copy it and use it. This one. Copy, which is from the interface test. Private key. Let's paste it here. Paste. The IP address on the client side is 10.10.10.100/32, and the DNS IP addresses, which will be assigned when the VPN client will be activated, is 1.1.1.1 and 8.8.8.8. We can also record the public key which we use it for the server in case we want to use it in future. Let's paste it here. Now we can delete the test interface. We don't need it anymore. We select it and remove it. Then we have to add the public key of the Paris headquarters. In order to get it, we go to this menu, copy it from here, and paste it here. Paste. And we need to copy the new generated pre-shared key. Copy. And paste it here. The endpoint IP address. This is the server that we are going to connect. In our case, it is our WireGuard 1 port, which is 172.16.3.2. 172.16.3.2 with the port 443 for the UDP. And the allowed IP address, as we are building a full tunnel, we say 0.0.0.0/0, and the persistent keep alive is 20 seconds. Let's save it, and let's save it as a configuration file. So now it's in the text file. Let's say conf. Looks like it's still in the text format. Let's change it to conf. If you change a file name extension, the file might become unusable. Are you sure? We say yes. Still not change it. Rename. Yes. Let's refresh it. Up, down. So we have a road barrier, WireGuard full tunnel configuration file, which we just created. What happened to here? Okay, now we need to somehow transport this newly created file, road barrier full tunnel. Let's give it a name to it. Let's say my name, destined for Enver. We need to copy this configuration file to the Windows 11 Pro. Normally we cannot copy paste directly to here from one machine to another. Let's try if we can. Copy. You see there is no paste option. But I have a Winbox here which can access our ISP router or Paris router. Without Roman activation, I can access my ISP router. Let's copy the configuration file to the ISP router. This is the ISP router. We can go to Files and go to our file and drag and drop it here. As you can see, file has been copied to the ISP router files root folder. Let's now create the split tunnel configuration also. For this, we take a copy of this text file. We say copy, we say paste, and let's give it a name. Split tunnel, let's say telephony. Why telephony? I will explain you a little bit later. Let's rename it and give it a name of Enver. Let's open it. The configuration which will be in the second file, in the split file, should be all same other than this allowed IP address list. We don't want to tunnel everything, we just want to tunnel specific subnets. Let's rename this one to text. And those specific subnets should be these ones: 192.168.3.0/24. Then we put a comment, say 192.168.2.0/24. Then we put a comment, say 192.168.1.0/24. And then we put a comment, say 10.10.10.10/0/24, which is the IP address of the tunnel interfaces, or IP subnet, this one. Let's say save. And maybe let's change the keep alive to 4 seconds. Say save. And then let's change its file name to the format which is understandable to the WireGuard client. It should end with con. Okay, now let's copy this configuration also to the router ISP file folder. So we have in the router ISP road variable WireGuard full tunnel and split tunnel. Now let's try to access that configuration from the road variable mobile client, which has a Winbox installed and which can have access to the ISP router, which is on 172.16.20.1. 172.16.20.1. Let's say connect. And as you can see, we have connected to the Mikrotik router of our ISP. We can see these two files. Let's copy them to the desktop by dragging them. And we can now close this Winbox. So we have a full tunnel configuration and split tunnel configuration. And we have installed here a WireGuard client already. Let's try to find it. WireGuard, yes, it is here. And we have here some clients which I tested previously installed. Let me remove them. Remove. Remove. And this one also remove. And let's import these two client configurations. We say add tunnel. No, we should say import tunnel from file. First of all, full tunnel. Unable to import configuration. Tunnel name is not valid. Road variable something something. This kind of client doesn't like the long names with spaces. Let's fix that. Maybe now it will not complain. Import. Open. Again. Let's rename again. Maybe let's make it shorter. Import. Yes, looks like the length of the file name was not very suitable. So we have full tunnel. And let's also rename this one. Let's remove the empty spaces. Looks like it's fine now. So we have two tunnel configuration. One of them is full tunnel. When I click on it, you even can see that it shows the public key, the address of that tunnel interface IP, which will be assigned to our Windows machine, the DNS servers, and then the activate button. Then we see here that allowed IP address is 0.0.0/0. Pre-shared key is enabled. The public key, which will be used for the peer. This is the Paris public key. And this is our local public key. This is the Paris IP address and port and the keep alive settings. And the status is inactive. If we click on the split tunnel, we can see something similar, just the difference is that the allowed IP subnets are different and the keep alive is 4. So let's activate full tunnel. We click on activate and we see that the tunnel is up. And we see some latest handshake, some traffic passed through. Let's see on the Paris side if this is the reality. We don't need ISP anymore, we need Paris. Paris side show us some data, peers, road barrier client, and as you can see we have statistics for the endpoint of 20.2. (20.2, 2020.2) here, yes, correct. 20.2 current endpoint port, the port which is being used by the interface on the Windows 11 Pro, the RX and TX packets, and last handshake time. Looks good. Let's see if we are able to ping from the Windows road barrier the computers in the Berlin, London and Paris office. Let's open the command prompt and say ping. Let's ping 192.168.3.100. It can ping it. Let's ping 1.254, which is London office computer, and let's ping 2.254, which is Berlin office computer. Let's say trace road to Berlin. As you can see, it goes to 10.10.10.1, then it goes to 10.10.10.2, which is this one. Then it goes to 192.168.2.254, which is this computer. So it goes via the tunnel to Paris and then via the tunnel to Berlin. Let's do the same for 1.254. And as you can see, the traffic goes to 10.10.10.1, then it goes to 10.10.10.3, which is VPN interface of the London router, and then it reached the 1.254, which is the London PC. Let's check if we can log into the Paris computer RDP. We say remote desktop connection, which is 3.100 with the user Bob. It asks us for the password. Password was test123, and we say enter. And it's trying to connect to the FTP server in the Paris office headquarters to the Bob account from our road barrier mobile client. And as you can see, we are logged in with the Bob's credential. We see the Bob desktop file on its desktop. So we are having a tunnel. We are having a connectivity from road barrier in Istanbul to the Paris server computer. Let's close it. And let's disconnect the WireGuard tunnel and see if we can ping anything. Okay, now let's see how the traffic goes when the full tunnel is deactivated. In the current configuration, I have disabled both tunnels, and let's ping or trace route the 192.168.11.1 router, which was on the internet. Let's see how the packets will go. As you can see, they go to 172.1620.1, which is the gateway of the road barrier in Istanbul. Then it goes to 13.1, which is the router in the internet. Then 11.1, which is a router behind even that internet router. So now let's activate the split tunnel. Activate. As you can see, the split tunnel has two tunnels on the network 10.10.10/0, 1.0/24, 2.0/24, and 3.0/24. In this case, we can trace route again to the same destination and should see the same result. You see 20.1, 13.1, 11.1. What does it mean? With a split tunnel, all networks which do not belong to Berlin local area, London local area, or Paris local area are directly sent to the ISP. And let's check, for example, the Berlin office computer, which is 192.168.2.254. How it goes. As you can see, it goes to 10.10.10.1, which is the Paris office, then 10.10.10.2, which is the Berlin office, and then 192.168.2.254, which is Berlin office computer. Let's see how it goes to, let's say, 3.100, which is the Paris office server, this one. As you can see, it goes to 10.10.10.1, and then it goes to Paris router, then it goes to 3.100, which is the Paris server. So the split tunnel is working. Now let's come to the interesting point of the keep alive, persistent keep alive 4. What does it mean? Normally we were setting 20, or the WireGuard suggests to set it even to 25. But imagine a condition when you have a 5G or 4G network here instead of this cable connectivity. 5G and 4G networks could be very aggressive on the NAT. What does it mean? It means that they can kill your NAT after 10 seconds of inactivity, of the connection inactivity. And if you have somebody with IP telephony, let's say from London, who wants to call you via Paris, or from Berlin who wants to call you via Paris, or from Paris who wants to call you directly. If this kind of settings would not be activated, the NAT on the mobile network side could be closed, and somebody has to wait at least 15 or 10 more seconds in order for the call reach your, let's say, software IP phone on your computer. But with the settings of NAT keep alive of 4 seconds, we are making a condition when a service provider like 4G or 5G operator cannot time out his NAT connection, and always the connection stays up. In this case, whoever wants to call us, they could reach us immediately. This is all what I wanted to show you in this lesson. If you have any questions, you can ask them in the comment section of the video. See you on the next lesson. I highly recommend subscribing to my YouTube channel so that you don't miss any new lessons or setup guides that I release.